Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 8085 addressing modes. So addressing mode, the way of data to be accessed for that particular instruction will be called with the addressing modes. Look at this first addressing mode, immediate addressing mode. So it has the meaning of that immediately the data will be available in the instruction itself. So it supports this. So we have the data that will be present in the instruction itself. Look at this. So this will be normally 2-byte instruction. One will be for opcode and another will be for an operand. Look at the example. MVI B, 45. So move immediately B, 45. So immediately, that's why we have this I. So immediate instruction onwards we have this I. So MVI B, 45. The 45 will be moved to B register. So the immediate data will be available in the instruction itself. That's why this is called immediate addressing mode. Look at another example. LXI H, 3050. So here it indicates HL register pair. So that's why we take this data 3050. So HL, L becomes 50 and then H becomes 30. So HL pair will be initialized with this address of 3050. And then look at this another example, jump address. So directly jumps to that particular address. So address is directly or immediately mentioned in instruction itself. That's why it is called immediate addressing mode. Look at this second method, register addressing mode. So in register addressing mode, the data present in the operation available in the registers. So both the source and destination must be a register. So therefore the operation is performed with various registers of the microprocessor. So both sources and destination must be a register. Only in that case it will be called as register addressing mode. Look at the example, move A, B. This means that content present in B register will be moved to A register. So look at this. So both source and destination is a register. Look at the second instruction, add B. So add B, the meaning is A equal to A plus B. So accumulator content and B register will be added. After addition, the result also stored to the accumulator. So both sources, that is both two inputs and an output, all will be registered. Look at this, INR A. So INR A means increment A. So A equal to A plus 1. So all the source, destination, all are will be in, only we use this accumulator. So register addressing mode, always we use only registers in that instruction. Then only it will be called as register addressing mode. Look at this next addressing mode, direct addressing mode. The meaning is that directly the address is specified in the instructions. So this value will be considered as a location. The content present in the location will be moved to the registers. So the meaning is the address is specified directly in the instruction. That is the meaning for this. Look at this example, LDA 2050. That means load directly accumulator with the location of 2050. The content present in this location will be loaded to the accumulator register. Why it is called direct addressing mode? The 2050 address is specified in the instruction itself. Directly we are specifying the location of the data. This is not directly specifying a data. Directly we are specifying an address. So direct address, that's why we called as direct addressing mode. Look at another example, LHLD address. So load HL pair with this address. So we have some address like an LHLD 2050. That means the content present in this 2050 will be moved to HL. So HL is a 16-bit register. So that current address 2050 and next location will be considered for moving a data. So here also directly the address is specified. Look at this third example, in 35. So we are getting an input from the port address 35. So it may be sensor or any switches. The directly data will be moved from the port address 35. So all address will be specified directly. That's why it is called as direct addressing mode. Look at this next one. This is register indirect addressing mode. So here the address is specified indirectly in the register. That's why it is called the register indirect addressing mode. Look at the example, move A, M. The content present in this M register. So M is a memory, it points HL pair. So for example, HL pair is 4500 means the content present in 4500 will be moved to accumulator. Look at this next instruction, LDAXB. That means it loads the data from the BC register pair. For example, BC register pair is 5000 means the content present in 5000 location will be loaded to the accumulator. Look at this. STAXB. That means store the accumulator content to the BC register pair. So BC, it will be point some locations. For example, BC equal to 5000 means that 5000 location, the result of accumulator will be stored. So we can use the D pair also. So that means that example will be LEXD. So that means it indicates the D register pair. Look at this last one, implicit addressing mode. So or we can say it is an implied addressing mode. So here the operand will be available in the instruction itself. That's why this is called implied addressing modes. Look at the examples. This first one will be CMA, complement accumulator content. So all the zeros will be made as a 1, all the ones will be made as 0. So complement of accumulator. So no other data to be specified, the data will be specified available in accumulator itself. That's why it is called as a implied addressing mode. Look at this, another one be RRC, rotate right carry. So through this carry, that means that the accumulator register with this C, the data will be rotated right. Similarly RLC, so this is rotate left. So the data will be rotated left with the register and carry flag. Similarly we have this RC also. So we can perform rotate right or rotate left. That is RR for rotate right, RL for rotate left also. So if data is available in the accumulator itself, then it will be called as implied addressing mode. Thank you.